Okay, so now we move to the uh, primary process, but this one is a primary sedimentation tank, so PST. So this is a primary sedimentation tank, so you can see here. So the water will flow from the top, from the bottom here, and spray on, not spray, it's like flow out from the nozzle in the top, like this, and then this is a settling zone, and this one will be rotate. Actually, this one is like a rack, and rotate all the time, so that the sludge or the solid particle will be moved to this lower place, and then it becomes sludge. So sedimentation tanks simply entail the physical settling of matter due to its density, buoyancy, and the force of gravity. Most of the suspended solids in the wastewater are sticky in nature and fluctuate naturally, type 2 settling without the addition of flocculant. So through the sedimentation, the large solid can are removed in order to facilitate the efficiency of the following procedure. The tank is large enough that fecal solids can settle. Scum removal is accomplished by the heavy sludge scraper. Okay, so this is the PSD, something like this. After primary treatment process, nearly 50 to 70% of solid settling down under effect of gravity, and 25 to 55% of incoming over the air are removed. But the colloidal and dissolved constituent are not affected. Continue with the second the treatment. So this is composition of organic and inorganic. This one is related to you know, because in the wastewater treatment we use Arabic 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 condition, okay, Arabic reaction or Arabic condition to decompose our organic compound, organic matter. Okay, so here this is like just it's this example. For example, here this is related to pond. Actually, this is a pond. So why pond can be used for the to treat the wastewater, because you can see here oxygen plus water plus light, that's become with the algae. Okay, they become algae, and organic compound plus oxygen, it will be CO2 plus will be become uh, uh, CO2 plus water. Okay, and then organic compound plus oxygen, it will become organic uh, CO2 gas. Okay, actually CO2 gas plus water plus inorganic. Alright, inorganic, it becomes here, or this is on the top, and then from the bottom you may have organic compound. From bottom here mean, if you observe the lake on the top, uh, with certain depth, that's the oxygen can penetrate, can dissolve, but the lower depth, the oxygen cannot penetrate. So this is, we can divide into two: aerobic zone and anaerobic zone. So in anaerobic zone mean the depth that oxygen cannot penetrate. So organic compound, it will turn into organic acid because of bacteria, and this organic acid, you remember the fermented condition, so you will have like a juicy, right? So juicy is, this is the acid actually. So this organic acid will turn into CO4 plus uh, CO2 gas plus inorganic. This should be inorganic, so it become solid particle here. So this is the so this part is not the algae one, but this part is very important for us to understand the process inside the like activity sludge or trickling filter or even this one oxidation pond. And this part is important for sludge removal. Okay, sludge digestion. Okay, so type of decomposition we have aerobics, anoxics, and anaerobics. So what is aerobic? For sure, you understand. Aerobic is the condition that the environment that have that full of oxygen. Anoxic is environment that is in the transition zone between aerobic and aerobic, and aerobic is the condition that have no oxygen. Okay, so aerobic decomposition, electric electron scepter is oxygen, and end product will be uh, uh, CO2 and water and bacteria cell, that I call it inorganic. Inorganics, organic we become inorganic. So this one is solid particle, and then order potential is low. Okay, we have ecosystem, healthy system. Water treatment plant is dilutes waste. Okay, anoxics is electron acceptor is nitrate. End product will be nitrogen gas, CO2 and oxygen and bacteria cell. Order potential is low. Ecosystem upper hypolimnian. Okay, and wastewater is denitrification. In this wastewater treatment plant is we call it this is the condition of denitrification. So meaning that if we would like to remove the nitrate, we would like to remove the nitrogen, we can use this method, meaning that you introduce the anoxics phase. So in the wastewater treatment plant, usually this place is after the primary after the uh, after the primary, mostly is not primary. They will, after the aeration tank, they will introduce one unit where they call it this is anoxic unit. So this anoxic unit is you can see in the oxidation tanks, like the water is like very turbulent because of the oxygen is introduced, and then in the anoxic tank is they will let the water uh, stand still, stagnant. So it's stagnant for several minutes. I am not sure the time, but depend on the we can do we can take the sample and then see how long does it take to effectively remove the nitrogen, and then just introduce that time to that unit, and then the nitrogen will be removed. Okay, anaerobic decomposition, electron acceptor is CO2. Uh, an organic compound. So end product will CH4, CO2, oxygen and water and bacteria cell. And order potential is high. So ecosystem is a sediment, and the sludge is in the wastewater treatment plant. This is at the sludge stabilization, introducing the sludge stabilization. That's why I say anaerobics in wastewater. Usually anaerobic decomposition is introduced at the sludge digester. So this is how the microorganism work. So meaning that if from one cell like this, they will produce like 2 or 3 or more. Okay, through binary fission, one bacteria become two, two become four, and so on. Okay. Microorganism produced by binary fission. So mass balance concept, I think this one is you already familiar with it. So this is the to calculate the especially the volume. Okay, volume of the tank, and also how much BOD can be removed in the system. Okay, so this is mass balance wastewater. We have flow in, complete mix reactor, and then flow out. Wastewater secondary treatment. So typically utilize a biological treatment process in which the microorganism convert to a non-soluble solid to soluble solid. Okay, non-soluble solid to soluble solid. Provides BOD removal beyond what is achieved in primary treatment, and sedimentation typically flow. Okay, we stop this for a while and then we continue for the secondary treatment.